Hello viewers, welcome to the classes of calculus. Today we are going to discuss some important and essential rules for differentiation. Before that, we have to know what really the term differentiation means. What is differentiation? In simple terms, it calculates how one quantity changes with respect to another. So, differentiation is used to find the rate of change like speed or how fast something is going or shrinking. So it's a tool to find how fast one thing changes to another. It's used to measure things like speed, slope of curves, the rate of changes in different fields. The result of differentiation is called derivative. Mathematical notation of derivative is dy by dx. To know more about the mathematical expression of derivative, just we have to consider a function y equal to fx. So for this function, you can write the derivative of this function as dy by dx, and also you can denote this one by f dash x. So for a function which is defined in a certain interval, we have derivative is dy dx or f dash x. Mathematically, f dash x is equal to limit del x tends to 0, function of x plus del x minus function of x divided by del x, where del x is a small increment for x. So this is the mathematical definition of derivative of a function. Now let's discuss some working rules for finding derivatives of a function. Here are this. One is constant rule, next is power rule. You have constant multiply rules, sum and difference rules. You have also product rules. You have quotient rule and also chain rule. So these are the primary working rules for finding dy dx. What is constant rule? So for that, we have to take a function which is a constant one. So we take fx is equal to a constant which is denoted by c, and so our derivative of this function will be 0. So according to this rule, the derivative of a constant function is always 0. Next is power rule. Next is power rule. By this rule, you can bring down the exponent and reduce it by 1. That is, it will be a formula like this. If you have a function fx equal to x to the power n, then the derivative of the function is n into x to the power n minus 1. So this is the power rule which can be applied for finding dy dx. Now next, the constant multiply rules. If you multiply a constant by a function, then just differentiate the function and then multiply by the constant. Next one is sum difference rule. To differentiate sums or differences of two functions or more, differentiate each term separately and you will get the derivative of the whole function. The next one is product rule. For that, we have to consider two functions, which is f and g. So the derivative of the product of this two function is f into g dash, which is equal to, if you consider f as a first function, then you write it first function into derivative of the second one, that is g dash, second function, that is g, into derivative of the first one. So this is the product rule which can be applied frequently for finding derivative of a function. Next is quotient rule. Just as like as product rule, you have to take two functions here. It will be f by g now, and the derivative of this one is equal to, you have denominator g, and denominator square will be g square, and here denominator g into derivative of numerator, that is f dash, minus numerator, that is f, into derivative of denominator g dash. So you have this formula which is known as quotient rule, and you can also apply these rules frequently. Next one is chain rule, which is also an important rule. For composite function or function of a function, this rule is applied. Here you have to differentiate the outer function first and then multiply by the derivative of the inner function. So if you have a function like this, g of x, this is a composite function, and the derivative of this one is equal to derivative of the outer function into derivative of the inner function, that is x dash. So this is the chain rule formula, and you can apply this formula in various problems of derivative. So just follow these three rules very carefully, and you will see that the application of these formulas are very frequent.